Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today we again come up with a variation in the assignment model. So let us quickly move on to the problem, and the problem says that find the optimal assignment for the below matrix. Also show that it has a multiple solution. So a cost matrix has been given and we need to make an optimal assignment for this particular matrix, and we also show that this matrix possesses multiple solution, which is also known as alternate optima. So let us start solving. So the first step is that our matrix should be a square matrix. So we can see that it is already a 4 cross 4 matrix, that means it has already been a square matrix. Now the second step is to reduce the matrix in such a manner that each row and each column has at least one zero in it. So for that we will first do the row reduction and then the column reduction. In row reduction we will select the minimum value in a column. Suppose for row 1 the minimum value is 2, and all the elements of this row are subtracted by this minimum value. Similar can be done for column reduction for each column. So let us start. First we will do the row reduction, and we can see that for row 1 the minimum value is 2. So 2 minus 2 is 0, 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3. For second row the minimum value is 4, so 4 minus 4 is 0, 5 minus 4 is 1, 6 minus 4 is 2, 7 minus 4 is 3. Moving on to row 3, the minimum value here is 7, so 7 minus 7 is 0, 8 minus 7 is 1, 9 minus 7 is 2, 8 minus 7 is 1. Moving on to last row, the minimum value is 3, so 3 minus 3 is 0, 5 minus 3 is 2, 8 minus 3 is 5, and 4 minus 3 is 1. So as we can see that now we have at least one zero in each of the row. Now we need to do column reduction. For that we will select the minimum value in a column and subtract each element of that column by that particular minimum value. So for column 1 we can see that all the values are 0, so it will remain as it is. For column 2 the minimum value here is 1, so 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0, 2 minus 1 is 1. Now column 2 the minimum value is 2, so 2 minus 2 is 0, again 2 minus 2 is 0, 2 minus 2 is 0, 5 minus 2 is 3. Now in column 4 the minimum value is 1, so 3 minus 1 is 2, again 3 minus 1 is 2, 1 minus 1 is 0, 1 minus 1 is 0. So now we have reduced our matrix so that we have at least one zero in each row and in each column. And the next step is to assign or to make an assignment in this matrix. And to make assignment in this matrix, first we will assign row wise, then column wise. If there is a single zero in a row, we are going to assign that, and if there are more than one zero, then we will skip this row and move on to the next row. Similar is the case with column. So let us see. So if we move from row 1, we can see that it has more than one zero, so we will skip. Row 2 is also having more than one zero, so again we will skip. Row 3 more than one zero, so we will skip. Row 4 more than one zero, so we will skip. Now we will move column wise. Column wise has more than one zero, so we will skip. Column 2 has more than one zero, again we will skip. Column 3 has more than one zero, we will skip. Column 4 has more than one zero, so again we will skip. Now as we can see that because there are larger number of zeros here, we are unable to make assignment through proper method. So what we will do is we are going to select a zero arbitrarily, and on the basis of that we are going to assign the remaining values. So let us first select cell 1 1. So I am going to assign this cell, and after making assignment here no more assignment can be made in this particular row and in this particular column. That means all the zeros in this particular row and this particular column is going to be crossed out. Now moving on to row 2, we have more than one zero, so we will skip this. Moving on to row 3, we have more than one zero, so we will skip this. Moving on to row 4, we have single zero. Okay, previously we have two zeros, but this zero has been crossed out, so this zero is ineligible for assignment. So there is one zero only in this particular row, so we will assign this zero, and once this zero has been assigned, no more assignment can be done in this row and in this column. That means this zero is also going to be crossed out. Now again we are moving row wise, so we can see that row 2 is having more than one zero, so we are going to skip this. Row 3 is also having more than one zero, so we are going to skip this. And if we move column wise, column 1 is assigned, column 2 has more than one zero, so we will skip this. Column 3 has more than one zero, so we will skip this. So as we can see here also, we are not able to assign by proper method, so again we need to assign any of these zero arbitrarily and select or assign the remaining assignment. So let us select this one, cell 2, and once this has been assigned, no more assignment can be done in this row and in this column. So these two zeros are crossed out, and now we can see that only one single zero is remaining in row 3, or we can say column 3. So we can assign this easily, and after this we can see that we have 4 assignments in a 4 cross 4 matrix. That means we have our optimal solution here, and after obtaining optimal solution we will calculate the minimum z that is coming. So this optimal solution is also optimal for this particular matrix, so we will select the value from the original matrix. So that is 2 plus 5 plus 9 plus 4. So here 7 plus 9, 16 plus 4, 20. So the minimum value coming here is 40. Now the question arises, because we have chosen an assignment arbitrarily, what if we have not chosen this cell and we have chosen any other cell? So let us do that and see what are the changes in the matrix occur and what will be the value of objective function for that particular matrix. So I am going to write this matrix again: 0 0 0 2 0 0 0 2 0 0 0 0 0 1 3 0. Now let us this time assign this particular cell, that is cell 4 1. So now previously we have assigned the cell 1 1, okay, here, and this time we are starting with assigning cell 4 1. Both the values are having 0, so we can assign any one of them. So let us this time assign this particular cell, and once this has been assigned, no more assignment can be done in this row and in this column. So we are going to cross out all the zeros in this particular row and column. And now again we will try to assign by proper method. So if we move row wise, row 1 has more than one zero, row 2 has more than one zero, row 3 has more than one zero, row 4 has been assigned. Now moving on to column wise, column 1 is assigned, column 2 has more than one zero, column 3 has more than one zero, column 4 has a single zero now. Okay, so because column 4 has single zero, we are able to assign this 0, and once this has been assigned, no more assignment can be done in this column and in this row. So these two cell zeros are going to be crossed out. Now as we can see here, we are again in a situation where if we move row wise, in row 1 we have more than one zero, so we are going to skip this. In row 2 we have more than one zero, so we will skip this. and row 3 and row 4 are already assigned. And if we move column wise, column 1 is assigned, column 2 has more than 1 0, so we will skip this. Column 3 has more than 1 0, so we will skip this. So again we are not going to again we are not able to assign the values by proper method. So again we are going to select any of these 0 arbitrarily and select the remaining assignment. So let us assign this cell, and once this cell has been assigned, that means no more assignment can be done in this row and in this column. That means both these zeros are crossed out, and as we can see now, only a single 0 is remaining in row 2, or I can say column 3. So this 0 can be easily assigned, and now this is our assignment. And as we can see here, we have 4 number of assignments in a 4 cross 4 matrix. That means this solution is also optimal for this particular matrix, and if this is optimal for this matrix, this solution is also optimal for the original matrix. And now let us calculate the value of z here. So z minimum here is coming as, this is 3 plus 6 plus 8 plus 3. So as we can see, 6 6 12 plus 8 20. So here again the value of z is coming as 20. So we can see that our solution has been changed. That means the assignments have been changed, but the value of z does not change. So let us see again that if we do not assign the value in this particular cell, or we will assign this cell any other cell, then what will be the effect? So let us just quickly see here. 0 0 0 2 0 0 0 2 0 0 0 0 0 1 3 0. Now this time let us assign some other cell and see what is going to happen there. So let us this time assign this particular cell 3 1. So once this has been assigned, no more assignment can be done in this row and in this column. So all the zeros in this row and this column has to be crossed out. So now once this has been happened, again we are trying to assign. So let us assign row wise. Row 1 is having more than 1 0, so we will skip this. Row 2 is also having more than 1 0, so we will skip this. Row 3 is already having an assignment, so we will skip this. Row 4 is having a single 0 now, so we can assign this particular cell, and once this is assigned, no more assignment can be done in this row and in this column. So again we can see that we are having 4 zeros, and if we move row wise, row 1 is having more than 1 0, so we will skip this. Row 2 is having more than 1 0, so we will skip this. And in moving column wise, column 2 is having more than 1 0, so we will skip this. Column 3 is also having more than 1 0, so we will skip this. That means again we are not able to assign here with a proper method. And again what we need to do here is we need to assign any particular cell arbitrarily and then see what we can do with the other assignment. So let us again assign this cell, and if this cell has been assigned, that means no more assignment can be done in this row and in this column. And once this has been assigned, we can see that only a single 0 has been remaining in row 2, or we can say column 3. So let us easily assign this row, and here also we can see that we have total 4 assignments in a 4 cross 4 matrix. That means this solution is also optimal, and for this particular solution the value of z minimum from the original matrix, let us calculate this. This is 3 plus 6 plus 7 plus 4. So as we can see, this is coming as 20. So as we can see that by allocating various different cells, we are obtaining different optimal solutions, but the value of z remains same in all the cases. This shows that there is a multiple solution occurs in for this particular problem, and this is also known as alternate optima. So we can see that here in this matrix the cost coefficient or the value of z, if we calculate, is 0. Similarly, in this matrix also the value of z, if we calculate, is 0. In this cell also the value of z, if we calculate, is 0. So because the value of z does not changing in this particular cells, the value of z also remains same for the original matrix. So this is the case where we do not find assignment by proper method, and if we assign arbitrarily, there is a possible chance that there may be another solution, or we can say multiple solution exist, and this is also known as alternate optima. So if you like the lecture, please share the lecture. Have a nice day. Thank you.